All right, so for 76, we're given this graph. It says the graph of function f is shown in the function above. For which of the values of x is f prime positive and increasing? You have guessed it, that is going to be this stick-it note. They want f prime to be positive and increasing. All right, f prime is positive. That means the graph of f should be increasing. And if f prime is increasing, that means the graph of f should be concave up. So we want to pick a point where the graph is increasing and concave up. So that is going to be at point E. The graph is headed upwards and it's bending upwards as well. So E for that one. All right, 77. Let f be a function continuous on the closed interval 2 to 4. They give us f of 2 is 10 and f of 4 is 20. Which of the following is guaranteed by the intermediate value theorem? Intermediate value theorem says as long as your function is continuous, you're going to have outputs in between these other two. So let me go ahead and draw this. I'm a real visual person. I just like to have a picture. We have the point 2, 10. So you'd have a point there. So 2, 10, and then 4, and then 20. I'm not going to make 20 tick marks, but you'd have a point here at 2, 10, and then at 4, 20. So if the function is continuous, when you connect those, and I don't know what it does in between, but it would be continuous. You wouldn't have any gaps. You're going to get all of the values in between 10 and 20. And for this one, they picked 13 specifically, but it says f of x equals 13 has at least one solution within this interval from 2 to 4. That's going to be your answer A. They picked 13 specifically, but they could have picked any number in between 10 and 20. You're going to get a result in there. I'm not going to go through all the wrong answers, but I do want to mention one of them. Which one was it? D. This says f prime of x equals 5 has at least one solution on 2 to 4. All right, if you take these 2 points, 2, 10, and 4, 20, if you do the slope for them, that's going to give you 10 over 2, which is 5. So you would have the derivative equal to 5 at least one point on that interval. The reason that D is not the answer is that's not intermediate value theorem. Does anyone remember what theorem that is? Because that's not intermediate value. You can abbreviate. Does anyone remember what theorem that is? Because that's one of the other theorems, and that one also comes up a lot. But the reason D isn't the answer is because it's not intermediate value. Does anyone remember what that one is? Where your slope equals your derivative? Average rate of change equals instantaneous rate of change. This is such a huge theorem. It's going to show up on your exam. Please let somebody get this. There we go. Thank you. Mean value theorem. Perfect. All right. So 2 issues. And the reason why that's not the answer here is number one, it's mean value theorem. And the problem said intermediate value theorem. And the second thing is, in order to use mean value theorem, the function has to be continuous and differentiable. And they didn't mention that it's differentiable. So that's why it's not D. But if they had said differentiable and mentioned mean value theorem instead, then D would have been the answer. Anyway, I just want to bring that up because that's also a really important theorem. All right, 78. We are going to need a calculator here because I see all these decimals. The graph of y equals, and then they give you some awful function, e to the tangent x minus 2, crosses the x-axis at one point on the interval 0 to 1. What is the slope of the graph at that point? And what they're asking you for is the derivative. They want the derivative at that point. Right, well, the first thing we have to do is find that point. So we're going to go to y equals, we're going to type in this function. So e to the power tangent of x, and then minus 2. And we want to make our window 0 to 1. So I'm going to go to window, oh, wow, mine is really messed up. I'm going to make a 0 to 1, count by ones. I'm going to leave the y as negative 10 to 10. We'll just leave that standard. So it says we're going to cross the x-axis at one point in here. And it's right about there. And so we're going to calculate that 0. So we're going to do second trace, calculate. We want to calculate a 0. Now this is the interval 0 to 1. So I'm going to make my left bound be 0, enter. Right bound is 1, enter. And I'm going to make my guess 0.5, enter. You can guess anything that's in between 0 and 1 and it'll show up. All right, so there's that point. And that's a choice. That's choice A, but that's not our answer because we're not done yet. We want the slope of the graph at that point. So here's what we need to do. We're going to quit out of here, bring it back hit X, enter, store it. So store alpha A, enter. So again, X, enter brings it back, store alpha A, enter to copy it. We want to do a copy paste. We want to find the derivative, says the slope at that point. All right, where do I get my derivative on the calculator? Because we do integrals a lot, but we can do derivatives too. How do I bring up the derivative on the calculator? Like what menu is that going to be under? Good, well remembered. Nice job, guys. All right, math 8. Perfect, nice, thank you. All right, so we're going to go to math 8, d dx. The function is going to go in there. So it's e to the power tangent of x minus 2. And then such that we want to copy and paste this value into there. So alpha A. So derivative of that function at the point that we found, and that will give us our answer. So 2.961, they always round up. They don't truncate for the multiple choice. 2.961, so that one is D. So I didn't do any work for that problem. It all happened, in the calculator. All right, 79, particle is moving along the x-axis. Velocity of the particle is given by v of t, and acceleration is given by a of t. That's kind of like no kidding. Which of the following gives the average velocity? All right, that is an average value. And it says on the interval 0 to 8. Whenever you're given an interval like 0 to 8, you want to think, integral. So you want an integral from 0 to 8 for velocity. But to make it an average, you need that fraction out front. 1 over 8 minus 0, which would be a 1/8. So 1/8 integral 0 to 8 of velocity, and that one is B. Which C was really similar. They just stuck an absolute value around that. You don't need an absolute value for an average value. It's just the right, number 80. Graph of f prime. All right, so be aware of which one they gave you. Graph of f prime. I have a feeling I'm going to pull out my stick-it note here. Shown above, which of the following statements must be true? All right, we have a Roman numeral 1. We have a relative minimum at x equals -3. All right, minimum means that your derivative changed from negative to positive. So relative minimum means from negative to positive. So that would be from below to above. So at -3, we do change from negative to positive. It goes from below to above. So that one is good. All right, Roman numeral 2. The graph of f has a point of inflection at -2. All right, a point of inflection is where your graph changes from concave up to concave down or vice versa. Now we're looking at f prime, and usually that's the one they give you. That's where this graph changes from increasing to decreasing or decreasing to increasing. Right, so the only place we would have a point of inflection is right here at 0, not -2. So that one is a no. So this is where you'd have a point of inflection, where we change from increasing to decreasing. But they did not say 0, they said -2. All right, Roman numeral 3. The graph is concave down from 0 to 4. All right, concave down is going to be where your derivative is decreasing. So we want to check if this graph is decreasing from 0 to 4. Yeah, that's what they said, 0 to 4. And so we are decreasing from 0 to 4. So that is true. So we want Roman numerals 1 and 3. And so that is E. All right, number 81. Water is pumped into a tank at a rate of, and then they give you this R of T, gallons per minute. Time is minutes since the pump was turned on. We had 800 gallons to start with, so that's the initial condition. How much water is there after 20 minutes? All right, you want to take what you started with, so 800 gallons, plus however much you accumulated in those 20 minutes. So from 0 to 20. Now, it doesn't always start at 0, but this time it does because it says, I think it says from when the pump was turned on. So that would be, at time nothing. So, and then your rate function, which is the only function they gave you, is what goes in there. And it says to round to the nearest gallon. So we're going to type this in. 800 plus math 9, 0 to 20. And then that rate function is what's going to go in here. So 30 parentheses, 1 minus e to the power negative 0.16x, close parenthesis, dx. Again, they are not going to give you nice functions. They're going to be obnoxious to type. So you got to practice typing these because that is a skill that you need. So we get 1,220 gallons, and that one is D. All right, 82. If f prime equals this crazy function, then f has a local maximum. Remember, local means relative. So relative maximum at, now this is similar to number 80 that we did with the graph. It's just instead of handing us a graph like they did on this one, we are going to have to graph it ourselves. A local maximum means your derivative changed from positive to negative. So again, maximum means change from positive to negative. So we are going to type in this function and see where it changes from above sea level to below sea level. But first we got to type this in, all right? So this is square root next to the first plus 1, and then outside of that, plus x cubed minus 3x. Did we get a window? They did not give us a window. So I'm going to zoom number 6 for standard. And just because they didn't give us a window to work with, but we do have those 5 choices. So it's got to be one of those 5 choices. So we want where this changes from above to below, that's going to be right there. So from above the x-axis to below is going to be this point right there. And I'm going to calculate that. So calculate 0. And it looks like it's in between 0 and 1. You could zoom in on this if you wanted to. I don't want to take the time to do that, but you could zoom in on it if you wanted before you calculate this. It looks like that's in between 0 and 1. So I'm going to make my left bound 0, enter. Right bound 1, enter. And then I'm going to guess a half, 0.5. And see what it tells us. And so there it is, 0.350. And so that one is C. All right, for 83, they give us this graph. It says the graph above shows the velocity in feet per second of a car from times 0 to 8 times in seconds of the following, which is the best estimate of the distance traveled by the car from time 0 until it comes to a complete stop, which happens at 8. That's where your velocity is 0. So car's moving and then comes to a complete stop. What they're asking you to do is accumulate how far it went, how many miles it went from, or was this feet, how many feet it went from 0 to 8. So we want to do an integral from 0 to 8. The thing is, we don't have a function to type in the calculator to work with, so we have to just estimate it. So we want the area under this curve from 0 to 8. So it says estimate. You just have to do your best job. What we want to do is count up the little boxes that are under here to get the area under the curve. So let's see how many we've got. 1, 2, 3, 4, 5. I'll count that one. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Should I count that last one? 21. We'll count that. We'll say there's about 21 little boxes under there. Again, it's like as good as you can get. There's 21 of them, and they are worth 10 each. It's 1 by 10. So that would give you 210 feet. Again, it's like just good enough. Like I counted, like I left out these little ones, but then I counted some other ones. Like you're just doing the best job that you can. Basically. You're estimating that area under the curve. So D for that one. All right, number 84. For the interval negative 1.5 to positive 1.5, let f be a function with a first derivative. So giving us the derivative function given by, and then they give you that awful thing. Which of the following are intervals where the graph of f is concave down? Right, they ask a lot of stuff on this. Concave down is where your derivative is decreasing. So what we want to do is type this in and look for where it is decreasing. All right, so let me get back to y equals. I'm going to clear that out. We're going to type this in and look for where it's decreasing. So this is e to the power x to the 4th minus 2x squared plus 1, and then minus 2. And we are given a window, so I'm going to go back to window. It's negative 1.5, positive 1.5. And again, it says we want F to be concave down. This is not the graph of F though. Remember, this is F prime. So concave down would be where this graph is decreasing. Now, because we have choices, I'm going to kind of just look at what I've got on the graph here and see which choice makes sense. So I don't really have to calculate anything here. It looks like we're decreasing from negative 1.5 until here, which is about negative 1. So negative 1.5 to negative 1. And then we're also decreasing from 0 until, what is that, positive 1 until 0 to 1. So that one is going to be D. So negative 1.5 to negative 1, we're decreasing there, and then also from 0 to 1. So D for that. All right, 85. The graph of F prime, and usually they give you F prime. When you do anything with this stick-it note, usually, like 90% of the time, they give you F prime. Occasionally, they give you the second derivative or the original function, but usually this is the one they give you that they want you to interpret. So here's the graph of F prime, looks like mountains. Derivative is shown in the figure above. We want to find where there's a local maximum. Again, that's a change from positive to negative. And that happens here at 1. We have a change from above to below. So that happens at x equals 1. So that one is C. All right, number 86. If first derivative is positive, greater than 0, first derivative is positive, and integral from 4 to 7 of the function is 0, which of the following could be a table of values for function f? All right, let's deal with this first, because this is going to be process of elimination. If the first derivative is positive, what does that mean our function should be doing? I haven't thrown a question at you guys in a while. If your first derivative is positive, what should the values in our table be doing? Positive means they should be doing what? Good, nice job, guys. Increasing. Okay, perfect. So we can eliminate anyone where the values aren't increasing. So negative 4, negative 3, 0, those are increasing. These ones are increasing. From 6 to 3, that's a decrease, right? So we can get rid of C. This is constant, so that's not increasing. And this one is increasing. All right, so we've narrowed it down to A, B, or E. Now we're going to look at the second piece of information they gave us, which says the integral from 4 to 7 should be 0. That means the area under the curve from 4 to 7 cancels out. Like you have some area, this isn't going to be real accurate here, but from 4 to 7, the graph's increasing. You have some area that's below and some area that's above, and it cancels out and you end up with 0. This isn't exactly what the graph's going to look like. That's just to give you a visual. Some should be below and some should be above so that you can end up with it being 0. So if you think about A, you would have points negative 4, negative 3, 0. That's going to be entirely below the x-axis. So it cannot be that one. Negative 4, negative 2, 5. That's going to have some area that's below and some area that's above. So that one's good. So that's going to be your answer. D, if you have 0, 4, and 6, that area is going to be entirely above the x-axis. So that's why it cannot be. So you're going to approach that as like a process of elimination. All right, 87. The graph of the second derivative. Okay, so this is one of these rare circumstances where they don't give you the first derivative. In this case, they're giving us the second derivative. Is shown from negative 2 to 4. What are all the intervals where the function is concave down? All right, so concave down is where the second derivative is negative. Remember, you're looking at the second derivative this time. That's sort of awkward because they don't typically do that. But negative means below the x-axis, below sea level. So we're just looking for where this graph is negative. So that's going to be underneath. So that would be this portion. So from negative 2 to negative 1. And then also this portion right here, so from 1 to 3. So let's see, negative 2 to negative 1, and then also from 1 to 3. So that one is E. All right, 88. Well, this is a related rate one. The guy walking away from the traffic light. Person whose height is 6 feet is walking away from the traffic light. Not a traffic light, what is this? Just a street light, right? He's just walking away from a lamp. Sorry, it's not a traffic light. He's 6 feet tall. That's constant because he's not growing or shrinking. And the street light is also also not growing or shrinking, and it says that that is 15 feet tall. Right, he's walking at 4 feet per second. So that means the distance between him and the street lamp is changing. So I'm going to call that x. That needs to be a variable. And his rate, dx dt, is 4 feet per second. So he is walking at 4 feet per second. At what rate, or what is the rate at which the person's shadow is lengthening? So that's from him to the end of his shadow. That's this distance. I'm going to call that y. And dy dt is our question mark. And it should be positive. All the choices are positive because it says that his shadow is lengthening. So we need to set up a relationship between the variables. It's going to be, a ratio of the right triangles in here, the big triangle and then the little triangles, like the mommy triangle and the baby triangle. So 15 is going to match up with 6. So 15 over 6 equals the whole side, which would be x plus y, over just the smaller side, which would be y. So again, it's the big side compares to the smaller side. And then the same thing for down here, the big side, x plus y, compares to the smaller side. We're going to cross multiply. So that'll be 15y equals, and then you have to distribute the x through there. And then I'm going to subtract this over so we have all the y's together. So that'll be 9y equals 6x. And then the derivative, it's like one of the easiest derivatives. It'll just be 9 dy dt equals 6 dx dt. And you plug in what you have and solve for what you're missing. So dx dt is 4. So that would be 24 divided by 9. And so what those will both divide by 3, right? So 8/3 feet per second. Oh, they did it as a decimal though. So 8/3 would be B, 2.223. So B for that one. All right, 89. A particle is moving along the line, so its acceleration is given by, oh, this is also strange. They gave us acceleration. Usually they give you velocity, right? This time they gave us acceleration. They gave us an initial condition for velocity. If the velocity at time 0 is 5, what is the velocity at time 3? Okay, well, you're going to take what you started with, which is 5, and add on your change. Now they started it at time 0, and we want to go to time 3. So 0 to 3, and then your acceleration function is what goes in there. So it's the initial condition, what your velocity was, what it started with, and then we want to accumulate velocity from time 0 to time 3. All right, so we're going to make it out of there. So we're going to type this in. It'll be 5 plus math 9, 0 to 3, and then this acceleration function is what goes in there. So it'll be x plus 3 over square root of x cubed plus 1 dx. So 11.710, so that one is E. All right, 90. Let f be a function such that, and then they give us integral from 6 to 12, f of 2x dx equals 10. Which of the following must be true? And then they give you all of these choices. All right, this is going to be a u substitution because it's not just f of x in there, it's f of 2x. So you'd want to let u equal the guts of the problem, the 2x. The derivative of that is just 2 dx. And we're going to adjust it with a 1/2. So in place of the dx, if you want to highlight that, in place of the dx, we're going to put 1/2 du. And what's in there is f of u. This equals 10, they told us. And then we just need to adjust the boundaries. So you're going to plug in the 6 and the 12 for x and see what you get for u. And you just have to double them. So if you plug in 6 times 2 is 12. And if you plug in 12, 12 times 2 is 24. And here's what they did. You notice none of these choices have a 1/2 out front. What they did is they multiplied both sides by 2 to move that 1/2 over. So you have integral from 12 to 24, f of u du equals 20. So if you multiply both sides by 2, that'll move that over. Also, I think they use t's instead of u's. Yeah, so they made it a t substitution instead of a u substitution. So they just called that variable t instead. Don't let that bother you. You can call it whatever letter of the alphabet you want. All right, so integral from 12 to 24, f of t dt equals 20. So this one is B. All right, 91. Let f be a polynomial function with values of f prime given in the table above. Which of the following has to be true from -2 to 6? All right, here's what I would do. I would just plot these. I'm a real visual person. I think it's nice to have a picture of what you're looking at. And it says that the function is a polynomial, which means that it's continuous and differential. All polynomials are continuous and differential. Right, so just to get a visual here, we're going to have -2, 3. Oh, I hope I left enough space for that. 0, 1, 3, 4, 5, 7, and 6, 5. All right, and you can connect them if you want. I don't know exactly what's going to happen in between these, but I know it's going to be continuous and differential. So looking through all the choices, let me tell you which one is the right one. And then if you have a question about why the other ones aren't, swing by office hours and I can go through that. Let me see, what is this one? It's going to be B. The graph has at least 2 points of inflection. Remember, what we're looking at is the derivative. And where the derivative changes from increasing to decreasing or vice versa, that's where you're going to have a change in concavity. And so this graph is going to have to change from decreasing to increasing and increasing to decreasing at least twice. It could change more times in between, but it's going to have to do it at least twice. So at least 2 points of inflection. All right, and then last one, number 92. Let R be the region in the first quadrant bounded below by the graph of x squared and above by the graph of y equals square root of x. So they even tell you which graph is above and which one's below. I'm still going to draw it just for the sake of us having a picture here. X squared would be the parabola, would be like that. And then square root of x is going to be something like that. So this is the area that we're looking at. At the base of a solid, you have to imagine these cross sections popping up out of the paper. They're perpendicular to the x-axis, so it's going to be a dx problem. And they are squares. So if I pull out one of the squares, the base of it is going to be upper graph minus lower graph. So that is square root of x minus x squared. And so I'm going to set up my integral. It is going to be from 0 to 1. These are going to intersect at 1, 1 there, because 1 is square root and 1 is x squared. So it's going to be the point 1, 1. So 0 to 1, and then the area of the shape is what goes in there. So a square would be base times height, and all the sides are the same since it's a square. So it's just going to be this squared and then dx. So that is what we're going to have to type in our. So we're going to do math 9, 0 to 1. And now you have to start your own parentheses. I know it's like, hey, there's parentheses already there. Those parentheses are going to go around the whole thing. You still have to start your own parentheses. So parentheses, square root of x minus x squared, close parenthesis, and then squared. So you do still have to provide your own parentheses inside of that. And that'll give you your answer. So 0.129, again, they're going to round up. So that one is A.